Hey everyone! In the lecture on web scraping, there was an activity that we didn't get a chance to talk about in class, so I decided to record this video so that you have a worked example of what a web scraping exam style question may look like. So if you haven't looked at this activity yet, I'll give you a second to pause the video and take a look at the HTML document provided. Okay, now that you've looked at the HTML document, you should know that this is a very typical exam style question where you're presented with an HTML document and then provided with some lines of code and are asked, hey, what do these lines of code evaluate to? Or alternatively, hey, write a line of code that extracts this information out of the HTML document. Okay, in this particular example, the document has information about songs with the most streams on Spotify today in Canada. You can tell this exam question is kind of old. It was written in June of 2022. Okay, so the first question, part one, says, hey, how many leaf nodes there are in the DOM tree of the previous document? That is, how many nodes have no children? So remember, DOM stands for Document Object Model, and it's the way of representing this document as a tree. Okay, so if we try and sketch out what this tree looks like, we'll notice that there are two nodes at the root of the tree. Okay, one would be head, and one would be body. Okay, typically, HTML documents have a root node that is actually called HTML that would have both of these as children, but for brevity's sake, we didn't include that on the exam because then it would have to make this document even longer and even more indented. So we'll start with just head and body. Okay, the head node up here just has one child. It's this title node. While the body node has two children. This H1 and this table. Okay, so in body, we'll have an H1 and then a table. Okay, and it's worth noting that this title node here, that's a leaf. Like there's nothing, sort of further down from the tree from it. In other words, it doesn't have any children. So that's one of the leaf nodes in this document. Same with the H1, right? The H1 doesn't have any nested tags in it. So that's a leaf node. Now the table itself is not a leaf node because within the table, you can see there are several table rows. TR, 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 TR. So we're going to have a row, a row, a row, and then another row. Those themselves are not leaves. The leaves are the THs within them. Okay. TH in the first example, and then these TDs in the latter three. Okay, so the DOM is going to look something like here, TH, 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 and then down here we're going to have TD times 3, TD times 3, and TD times 3. Okay, you don't really need to sketch all of this out for the purposes of answering this question, but I wanted to have an example of how you might sketch this out. Okay, so then the question is, how many leaf nodes are there in this entire tree? Well, it's 1, 2, 5, 8, 11, 14. Or in other words, there are 12 sort of table elements, these 12 plus the title and H1. So the answer there is 14. Okay, I'll screenshot that just so we can save the indentation somewhere else. But the answer to part one is 14. Okay, and again, you didn't have to do all of that sketching out to answer that. You could just see that 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 were the nodes with no tags within them. Okay, so the answer there is 14. The next part asks, what does the following line of code evaluate to? Okay, so what does the following line of code do? Well, it's asking us to find all of the tags whose tag type is TD, which is a table element. Okay, and so this is really asking how many TDs are there? And the answer is 1, 2, 3, 4, 5, 6, 7, 8, 9. And so the answer here to part 2 would be 9. Okay, so what would happen? Soup.findAllTD, so that is this underlined part without the len, be a list of 9 tag objects, or a list of 9 soup objects. Okay, the length of that is just 9 then. But if we were trying to scrape out information from these tags, we might, or from these TD elements, we might say, okay, find all the TDs and then for loop through those TD elements and get the text attribute. Okay, that's how we might get the string Harry Styles or the string first class and so on. Okay, but the answer to this question is 9 because there are 9 TD elements. Okay, and the last part is, what does the following line of code evaluate to? soup.findTr.getClass. Okay, so the difference between findAll and find is that findAll returns a list of all instances of a particular tag. Since there were 9 TD tags, this gave us back 9 things. But soup.find just gives you the first instance of a particular tag. Here we're just saying, hey, find the first TR tag. Okay, we could have specified additional things, like we could say, hey, find the first TR tag that has a class attribute, or find the first TR tag that has a class of 3. We didn't do any of those things. We just said, hey, find the first TR, and the first TR tag is this one right here. Okay, so more specifically, this piece, soup.findTr, would give us back this object. So within there, we could, then do .find th if we wanted to. Okay, but anyways, once we found TR, we're then saying, hey, get this object's class attribute. And so this is only going to work if there is a class attribute at the very top of this object. And here there is. The class attribute at the very top of this object says heading, so this would evaluate to the string heading. Okay. So if you have any lingering questions with how to interpret this HTML document in beautiful soup terminology, or using beautiful soup methods, let us know on Ed. But hopefully this video was helpful in walking through that activity. Thanks for watching.